Alright, welcome. Today we are talking about special segments in triangles. So we're basically going to be using some of the rules we talked about before as far as like angles of triangles, adding to 180, and things like that, and combining them with a couple other terms we've already seen before. The first of which is the perpendicular bisector theorem. So if we remember, perpendicular means that the lines cross at a right angle. Bisector means that the lines are cut in half. So if we look at the picture, our perpendicular bisector is here. These two lines AB is cut in half. Our theorem tells us that if we have this in a triangle, that our triangle is then isosceles. In other words, the other two sides are the same. The converse of that is that if I am given that these two sides match and that this is perpendicular, it has to bisect this line, so therefore we know the base of the triangle is split in half. So how do we use this? Well, they're going to give us a picture, and they're going to ask us to find some measures. So if I'm looking for AB, and I know that A to D is 4.1, I notice the base of this triangle from B to D is split in half, and we've got our right angle, so that tells me that the two legs of the triangle must match. Therefore, AB is 4.1. And if you notice, you can kind of remember this by looking at the two right triangles and noticing that they're basically just mirror images of each other. For part B, we're looking for WY. Well, again, we have two matching sides here. We have our right angle. So that means that this guy right here has to match this guy right here because the base of the triangle, once again, is split in half. So if we've got 3 on the right, we've got to have 3 on the left. Therefore, WY must equal 3. Finally, now we can do one that sets up using algebra. So we're looking for the length of RT. We see that the base of the triangle is split in half, and we have our right angle. So therefore, QR and RT need to be congruent. So 2x plus 3 must be equal to 4x minus 7. So negative 2x plus 3 must equal negative 7. Negative 2x, therefore, must equal negative 10, which tells us x equals 5. We're looking for RT, so we're not done. Plugging back in, 4 times 5 is 20, minus 7 is 13, therefore RT must equal to 13. Alright, I will let you try 1A, 1B, and 1C on your own. Let's move along. This one we're not going to do a whole lot with right now, but we will touch on it a bit in our next lesson. But I just want to sort of introduce it here just in case we need it for a problem later. Circumcenter. So basically a circumcenter is the center of a circle that you draw that fits around the outside of the circle or the triangle. If we do this, we notice that this line, and this line all hit the circle. And since the circle is supposed to be the same size all the way around, we know that those 3 lines segments must have the same length. In other words, they are all equal to the radius of the circle. The circumcenter can be inside the triangle, but it can also be outside depending on the type of triangle. So for acute triangles, our circumcenter goes around the outside. If our triangle happens to be obtuse, the center of the circle is outside, and on a right triangle, it happens to be along the hypotenuse. Notice the circle always has to hit the corners of the triangle in order for us to draw it correctly. This is going to lead us into our angle bisector theorem. So before we said, a bisector means it cuts it in half. So an angle bisector simply cuts the angle in half. If we draw a bisector and put the little right angles, that means that these two segments are congruent. Converse is true as well. So if I look at the picture below it, the two marked sides are congruent. I've got two right angles, so that tells me that the angle has to be cut in half. So let's look at an example. Alright, so we look at the picture. We are looking for xy. So here's xy. I notice I've got my right angles. I notice my angles are the same, so the big angle WZY was cut in half. Therefore, the small segments must match, so XY has to equal 7. Similarly, if I am looking for JKL, I notice that I've got my little congruent marks. I've got my right angles. So if the lines are the same, and I've got some right angles, that means this angle here is bisected. So 37 degrees on the right side means there's also 37 degrees on the left side. Therefore, JKL must equal 37 degrees. Finally, look at one with some algebra. So we are looking for the length of SP. S is this point right here, so we want this guy. Again, we've got our right angles. The angle is marked as bisected or cut in half. Therefore, 3x plus 5 must equal 6x minus 7. So we'll solve it out. So we know that x equals 4. And since we want SP, we're going to plug it back in. So 6 times 4 minus 7 . So 24 minus 7 equals 17. So that is the value of SP. All right, I will let you do 3A, 3B, and 3C on your own. One more little thing to look at. So the in-center, sort of like the opposite little setup of the circumcenter, right? So this time we'll notice that the in-center is the middle of a circle that's drawn inside of the triangle. So in this case, all of the little perpendicular lines touch the circle, so those lines have to be equal. If we have two equal segments with the little perpendicular lines, that means the angles are also bisected. So let's look at example 3. All right, so we want to find JF first. So JF is here. We notice that we have 3 right angle boxes. So if we connect them to make our circle, it means we're dealing with an incenter, which tells us that these guys here are the same size. I noticed that they gave me 15 units from J to A, and they gave me 12 units from E to A. If we notice, that makes a right triangle. And if we recall, right, A squared plus B squared equals C squared is the equation that we use to solve for the sides of a right triangle. I know that I can use 12 for my B and 15 for my C. And so now I can solve it out and get A. Alright, so we get A equals 9. A is the same length as JF, so therefore our final answer for that, JF equals 9. Alright, next up we need to find the measure of angle JAC. Again, we said if we see perpendicular lines and congruent segments, it means our angles are bisected, so that means this guy here has to be 32 degrees as well. We've got 34 degrees there, so I need 34 degrees here, which means this angle totals up to 68 degrees. This angle totals up to 64 degrees. So like we were talking about before, we can use the 2 angles we know to find the third angle of the triangle, because the triangles together need to be 180 degrees. So 64 plus 68 is 132, which means the missing angle from the big triangle needs to equal 48 degrees. There's going to be 48 degrees over here. If the angle is bisected, that means each piece of the angle is half as big as the total. So we're looking for JAC, measure of JAC. It's 24 degrees. Alright, that leaves one more example for you. That's all we have for today. I will see you next time.